Hello students, good morning. Welcome to the online lecture of Emerging Trades in a Mechanical Engineering. Today we are going to discuss about unit number 2, that is process engineering. The course outcome for this unit is the students are able to apply the heat engineering principles in the process boiler and waste heat recovery system used in process industry. The unit outcome number 1 is students will able to define the process boiler at the end of this session. So today's agenda is understand the concept of process boiler, understand the role of steam in the process heating applications, as well as understand the working of steam trap.
We have learned already about boilers. Boiler is a vessel which generates steam at high pressure and temperature from water using fuel or electricity. Process boilers mainly supply hot water or steam needed for various manufacturing industries or processing industries. Process boiler do not cover space conditioning, surface water heating, ventilating of building, as it relates to human occupancy and not any treatment on a product. Few common examples of such industries where process boilers are used are food industry, pharma industry, oil refineries, chemical industry, plastic, paper, sugar, textile, rubber, animal food production, etc. industries. Typically, process boilers have steam generation rate ranging from 175 kg per hour to 55,000 kg per hour. Typical power outputs are ranging from 85 kilowatt to 38 megawatt. Power output here indicates amount of heat that is supplied by boiler. There are different types of process boilers. Based on construction, there are coil type and shell type boilers. In coil type, water is in coils and these are small capacity boilers. In shell type boilers, water is in shell and these are large capacity boilers. Based on geometry, they are classified as smoke tube boilers, where gases pass through tubes and water is in shell, and water tube boilers, where water pass through tubes and gases are in shell. Based on fuel used, these are fossil fuel boilers using conventional fuel like coal, oil or gas, and biomass boilers which use promising alternate fuels like rice husk, groundnut shell, cashew nut shell, palm kernel shell, and so on. Lastly, based on quality of steam generated, they are classified as saturated boilers which supply wet steam used for process heating mainly, and superheated boilers that supply superheated steam which is used for power generation. The slide shows you various images of typical process boilers. You can see small capacity coil type boilers are mounted on skids and they don't require any special foundation. Also, you can see monoblock burners are used in large capacity oil and gas fired shell type boilers. Monoblock burners houses both the combustion blower as well as fuel burner in same unit. Also, you can see other two types of boilers: small capacity solid fuel boilers and large capacity solid fuel boilers in the slide. Let us discuss trends going on in process boilers. First are packaged boilers. They are just like washing machine. When you bring it from the shop, you just connect it to electricity and water and you start using it. In the same fashion, packaged boilers are ready to use boilers. All the accessories like combustor, pumps, fans, monitoring and control systems are all assembled in factory itself. Also they require less space and there is a lot of saving in cabling, piping, insulation activities. Secondly, automation going on in process boilers. Conventional manual fuel feeding and ash removal systems are replaced by automatic systems. Latest boilers are using green fuels like rice husk, palm kernel shell, groundnut shell, etc., which is popularly known as biomass, thereby reducing lot of pollution. Efficiency of boiler is also greatly enhanced. As you know, the fuel accounts 80% of the boiler's operation cost. Saving in fuel is very important. Waste heat recovery systems like air preheaters, economizers are used. Also, the combustion technology is also improved, which all is contributing towards better efficiency. Let us now discuss few applications. Process boilers are used in food industry. The applications are peeling off potatoes by sudden striking of steam. Also parboiling rice. It's a kind of rice that is boiled incompletely that helps to retain the nutrients in this rice. Second important application is breweries. You know the barley malt is first milled and then there are three processes like mashing, which is carried out at 66 degrees centigrade at 60 minutes. Lautering process where solid grains are separated from sweet water, which is carried out at 77 to 79 degrees centigrade for 3 to 4 hours. And then the hops are added and the mixture is boiled for 1 hour at 100 degrees centigrade. All these processes need steam. Next few applications include sugar mills. They use bagasse as a fuel. The steam is typically produced at 45 bar and 250 degrees centigrade or 67 bar and 485 degrees centigrade. The steam is supplied to a back pressure steam turbine where electricity is produced. The exhaust of the steam turbine at 120 to 140 degrees centigrade is given to sugar processing. And using this steam, the sugar is formed from the sugarcane juice. In dairy applications, pasteurization is carried out at 71.7 degrees centigrade for 15 seconds. Ultra high temperature heating is used to increase the shelf life of milk products, which is at 135 degrees centigrade and for 2 to 5 seconds. Also, milk powder production as well as flavored milk production is carried out at different high temperatures. This all requires process boilers. Steam is used in paper and pulp industry. It is used in heating and softening wooden chips. Also, it is used to heat the chemicals that are added in the wood pulp in paper manufacturing process. Also, steam is used to evaporate moisture from the pulp and to heat rotating dryer drums to dry paper stock. For corrugated papers, steam is used at 10 bar and 190 degrees centigrade. See some images are added from sugar industry, paper industry, parboiled rice, how it look like, and flavor milk. See some more images for process boiler applications. Flexi packaging. In this, various letters that are printed on this packaging, they are dried by using the steam. In corrugated paper manufacturing, in breweries, and also in dairy, already we have discussed. Let us come to a typical steam loop. A steam loop contains various elements like a boiler, steam distribution pipes for carrying the steam, heat exchangers for process heating like milk or sugarcane juice, etc., strainers for filtering the steam. Steam separators will necessarily remove water particles from the steam. Control valves, they will adjust the steam flow rates as per the requirement. Steam traps are important. They will allow the condensate to go out from the steam piping. And lastly, the vents which are meant for air. Observe in the figure on the leftmost side there is a boiler. The red color lines are carrying the steam to different process heating applications. First is a non-contact type, second is a direct contact type of application. Then there is a pressure reducing valve. On the right side there are few applications where low pressure steam is used. After doing its role, all the steam will get converted into condensate, which is shown by blue colored lines. Through the traps, all this condensate will go to deaerator tank. Deaerator tank's purpose is to remove the air or non-condensable gases, and after that the condensate will return back to boiler. Let us discuss something about steam traps. Boilers or steam systems are often closed loop systems. Water is heated, converted into steam in the boiler. Steam is used for process heating. Again condensate is formed and it is returned to boiler. Steam traps are fittings in steam systems which are used to remove condensate or air from the steam circuit and trap the steam. See the mechanical trap. The condensate will enter from left side. As the condensate level increases, the float will move up, it will open a valve and the condensate will be discharged to the atmosphere. As the condensate level drops, the float will also come down, thereby closing the valve and thereby closing the trap. In thermostatic trap, there is a bimetallic spring which expands on heating and contracts on cooling. The spring is connected to valve. Initially, spring is cold, so valve will be in open condition, and when the steam condensate enters in the piping, all the air will go out from the trap. Once the steam enters, because of high temperature, the spring will expand and it will close the valve, thereby preventing any loss of steam to the atmosphere. Again, when the condensate is formed, the spring will contract because of low temperature condensate, and again the valve will open and it will drive out the condensate. In thermodynamic traps, the steam condensate will come from the left side. It will enter the trap. Initially there will be straining action, then the condensate will move up. Because of the inertia of the condensate, the disc will be lifted up from its position and the condensate will go out from the condensate out pipe. Once the condensate is exhausted, the disc will again come back to its position. Steam traps will avoid any possible water hammer. There will not be any problem of blown seals, and also there will be reduced downtime of the entire steam system. Thank you.